Hello everyone, this is Mrs. Reed and this is lesson 5.2a. In the previous lesson, you learned how to solve systems of equations by graphing. Today, we are going to solve systems of equations by substitution. Our essential question for today: how do I solve a system of equations using substitution? When two lines are given to us in y-intercept form, graphing is one way to find the solution, but another way is substitution. Alright, so example A, solve using substitution. We have y equals x plus 3 and y equals negative 2x minus 3. Both of these equal y, so I can set x plus 3 equal to negative 2x minus 3. Or we can think that this part here is what y equals, and we're going to put it right here instead of y. So x plus 3 is what y equals, so I'm going to put that where y is here. So I'll have x plus 3 equals negative 2x minus 3. Now looking at this, the only variable I have in this equation is now x. So I can do what I've always done and just solve for x. I'm going to balance and solve. So I'm going to start by getting all of my x's on the same side. So I'm going to add 2x to both sides. So then 2x plus this 1x right here is 3x. I still have a plus 3. That equals negative 3. Because my negative 2x plus 2x is 0, so I'm left with 0 minus 3, which is the same thing as negative 3. Keep going. I'm going to subtract 3 on both sides. 3x equals negative 6. Now this 3x is multiplying, so to undo multiplication I divide by 3 on both sides. X equals negative 2. So we have the first part of our solution, but we also need to know what y equals, because this is a system of equations where we have two variables. So to do that, I need to pick one of my equations I was given, whichever I think looks easier. So I'm going to go ahead and pick the top equation and write that down. Y equals x plus 3. But now we're going to use what we found out x was. And we found out that x equals negative 2. So where x is, I'm going to put a negative 2. So y equals negative 2 plus 3. So then we simplify. Y equals negative 2 plus 3 is 1. So we get x is negative 2, y is 1. Another way to write that is as an ordered pair. Remember, we read it as x and then y. So x is negative 2 and y we got 1. Remember, it's always a good idea to check your answers. So we solve for x and y, and then to check our answers we plug in what we got for x and for y. So if I take one of the equations, y equals x plus 3. But instead of y, I know y is 1. Equals, instead of x, I know x is negative 2 plus 3. So I substitute in for x and y. And 1 equals negative 2 plus 3 is 1. And since we got a true statement at the end, 1 equals 1, we know that the ordered pair we checked is correct. So this right here is how we checked. So maybe make a note of that, so when you look back at your notes later, you'll see that's how we check our answers. Alright, so sometimes we might run into a problem where one equation has one variable where it's solved, like x equals, and the other is in standard form. Substitution works well in these cases too. So looking at example B, the first one here, we have x equals y minus 1. X is all by itself, we have x equals, and we know that it equals y minus 1. So now I'm going to look for x in my other equation, and that is where I'm going to put y minus 1. So I'm going to rewrite the equation, negative 8, then I'm going to put something there, so I'm just going to use some parentheses and leave a space, plus 2y equals negative 16. And in that space, I know I need something that is equal to x, and we know that x equals y minus 1. And now if we look at our equation, we only have the variable y left. So just a reminder, when you're solving with substitution, it doesn't matter whether we solve for x or solve for y first. We're just going to do whatever seems easier. So for this problem, we already had x by itself, so we substituted what it equaled in, which means we're going to figure out what y equals first. It doesn't matter which you find first, you just need to make sure that you find both x and y. So we're going to distribute. So negative 8 times y is negative 8y. And then negative 8 times negative 1 would be positive 8. And then we don't distribute anymore because that was the entire group. So plus 2y equals negative 16. So I want you to take a couple minutes here and go ahead and finish solving for y. So go ahead and get y by itself right now, please. So you should have started out by combining like terms. Negative 8y plus 2y is negative 6y. And plus 8 equals negative 16. So when we subtract 8 from both sides, we get negative 6y equals negative 24. So we divide by negative 6 on both sides. And negative 24 divided by negative 6 is positive 4. So we found y, but now we need to find x. So we take one of the two equations we were given, whichever looks easier. I think the top one does. So x equals y minus 1. X equals, and we know y actually equals 4. So we're going to, instead of y, we're going to put 4 minus 1. 4 minus 1 is 3. So x equals 3. And we can write this as an ordered pair. Remember, we do x then y. X we got 3, and y we got 4. So our ordered pair is 3, 4. Which means if you were to graph these two lines, they would intersect each other at the point 3, 4. Alright, the next one we have x minus 2y equals 11, and y equals 4x minus 16. The y is all by itself, so I'm going to use that to substitute. Y equals this, so I'm going to plug that in where I see y in the other equation. So we write out the equation, x minus 2, parentheses, something that's equivalent to y, equals 11. So I wrote out that whole equation, but in that spot where I left a blank, it's supposed to be y, and we know that y equals 4x minus 16. So now if we look at our equation, we only have x, so now we'll be able to solve. X, and I'm going to start by distributing negative 2. Negative 2 times 4x would be minus 8x. And then negative 2 times negative 16 would be plus 32, and that equals 11. Alright, so again, I'm going to pause, and I'd like for you to go ahead and get x by itself, please. So finish solving for x. Alright, so you should have started by combining like terms. 1x minus 8x would be minus 7x plus 32 equals 11. So you subtract 32 from both sides. We get negative 7x equals negative 21. Divide by negative 7 on both sides. Negative 21 divided by negative 7 is positive 3. So you should have gotten x equals 3. So now we take what we got and we plug it into one of the equations. I'm actually going to pick the bottom one here. I think it looks like it'll be a little bit easier. Y equals 4x minus 16. So how I knew that that one would be easier for me is I look and see that y is already by itself, so it just means I'll have a little bit less work to do when I try to figure out what y will be. So y equals 4 times x, which we discovered x was 3, minus 16. 4 times 3 is 12, minus 16. Y equals negative 4. So then if we wrote our answer as an ordered pair, which again is the point where they would intersect, the two lines would intersect if we graph them, x equals 3 and y equals negative 4. Alright, example C. A cop sees a motorist going the opposite direction, run a red light, and decides to pursue him. The police officer must turn around and proceed back towards the intersection. When he arrives back at the intersection, he is going 60 miles an hour. The motorist is going 50 miles an hour and is 0.2 miles down the road. Write a system of equations using t for time and d for distance. To better understand this problem, I drew a picture. So here we have the motorist who's speeding. They speed through the intersection, running the red light. The cop was on the opposite side, decided to do a U-turn to then follow and pursue them. Alright, it says the motorist is going 50 miles an hour. So 50 miles per hour. And is 0.2 miles down the road. So from the intersection to the car, 0.2 miles down the road. And our cop is going 60 miles an hour when he's back at the intersection. So 60 miles an hour. Alright, so now we can write a system of equations using t for time and d for distance. So for the cop, our equation is the distance is equal to the speed that he's going, which is 60 miles an hour, for however long he's driving, time, plus his starting value. Now, our starting value is actually the intersection, and the cop, when he's going 60 miles an hour, he is in the intersection, at the intersection, so plus 0. Now for the speeder, or the motorist, whichever you'd like to call, it would be d equals, so the distance is equal to the speed that they're going, 50 miles an hour, times how long they've been driving, but the speeder is 0.2 miles down the road. So we also have to have a plus 0.2. So now we're going to use substitution to solve for the distance and the time, which will be the intersection when the two meet. So we have the distance equals 60t plus 0. I'm going to take that and plug it in where the d is in the other equation. So then I get 60t plus 0. I'm just going to drop that part because it's plus nothing, so I don't need to write it, equals 50t plus 0.2. So now we go ahead and solve. I subtract 50t from both sides. So 10t equals 0.2. Divide by 10 on both sides. 0.02. So 0.02, it's t, which was time, and we had miles per hour, so it would take 0.02 hours. To figure out the distance, we're going to plug 0.02 in. So I take one of my equations, I'm just going to go with the first one. D equals 60t. So the distance equals 60 times t, which is 0.02. And if we multiply 60 times 0.02, we get 1.2. And that's miles. So the cop would catch up with the speeder in 1.2 miles, and that would take 0.02 hours. But that's kind of confusing to me because I don't really understand what 0.02 hours is. So is there a way that we can take 0.02 hours and convert it to minutes and then to seconds? If so, what would I get? So how many seconds will it take the cop to catch the speeder? So if you take 0.02 and you multiply it by 60, that will give us 1.2, so 1.2 minutes. And then if you multiply it by 60 again to get it to be seconds, it would take 72 seconds. Now the question we have next is, could you solve this graphically? What would be the pros and cons for doing it this way? So yes, we technically could solve it graphically. I would recommend something like Desmos if we're going to be graphing it, but it wouldn't be ideal because our y-intercept is not a whole number, right? It's 0.02. So yes, we could, but 0.02 is not a whole number. So our y-intercept is not a whole number, which would make it really difficult to graph our starting point. Lastly, I'd like you to try example D on your own, solve using substitution, and then once you are done, you can check and see how I did it and see if you got the same thing as I did for x and y. So take a couple minutes here and go ahead and do example D. Alright, so if you went ahead and solved this, you should have gotten y equals -2 and x equals -1. And this concludes lesson 5.2a.